Let's say, so today we're gonna learn about estimating derivatives from tables. And so let's say you were given a function here that it's a differentiable function, meaning there are derivatives across its entire domain. And it shows you only these specific values, which I've shown in the table over there, or in the graph over there. Um, so they only give these specific values, and we don't know what's really happening in, you know, all in between. It could look like that for all we know. It can do that. We're not sure, right? But what we do know is that there are these specific points. Okay, and so the question here that the problem asks is estimate the derivative at an x value of 1.5. So right around here at 1.5, what is the derivative of this function? We're going to have to estimate it. And so if we have a table, we can easily estimate a derivative if we know what the meaning of the derivative is. And just to remind us, the derivative, so f prime, which is the derivative, this represents the slope of the tangent line, or the instantaneous slope of f. So this function is f, and so how could we estimate a derivative at this 1.5 moment rate? So in between here, how could we estimate the derivative? And it's really simple. It's just we estimate it by saying, well, we don't know exactly what the derivative or the slope is in here, but we can guess by finding an average slope right here and just do a slope triangle to find that average. And so one easy way we might remember for finding slope is the slope formula. You know, the y2 minus y1 over x2 minus x1. And so what are our two values today for these points? F of 1.5, we're looking at these two sets of points. So my y2 value is 6, and my y1 value is 5. And then my x2 value is 1.6 minus 1.4. And so when you do the math real quick, you get 1 over 0.2, and you can leave it like that. Or some of you might have access to a calculator and might just think, oh, 0 divided by 0.2 is just going to be 5. And so you can say the answer is 5, which is the estimated slope of 1.5. Estimated slope. And there you go. So that's the first example. Let's look at another one. So here we're given a table where it represents the temperature of water in a tub, and it's a increasing twice differentiable function, which just means the function's the temperature's rising over time, increasing, and it's twice differentiable, meaning that we can find a derivative and a second derivative, and they both exist. We know that there are units where W is the Fahrenheit and T is minutes. So what they're asking today is use the data in the table to estimate the W prime of 12. So let's start with that. So just like before, to estimate W prime of 12, we can look for a T value of 12 in the table. So there's 0, there's 4, there's 9, 15. So 12 is right between here. And 12 is right in the middle of 9 and 15. So we essentially look at these two coordinate pairs and do the same slope triangle. So we do y2 minus y1. So the 27 minus 23 all over 15 minus 9. And so you get 4 over 6, which is, you can leave it like that, or if you'd like to reduce, you can have 2/3. So there's the actual value of the w prime of 12 is 2/3. But it looks like they're asking us more. So they're asking, show the computations that lead to your answer, which we have done. And then using correct units, interpret the meaning of your answer in the context of this problem. So according to this, we have this top part was the change in w, and this bottom part was the change in time. So if we kind of think about it that way, the top would be the change in w, or we can say degrees Celsius over minutes. And so that's the units. And now they also want us to interpret the meaning. So what this means is that, well, what's happening here in this situation? We know that the water is what? What does this tell us about the water? Now remember, this is the w prime of 12, right? W prime represents the slope of the change of the water, and so the slope of the situation would represent the change in temperature over time. And so we can say the water is it increasing or decreasing, and how can you tell? Well, we know it's increasing because it has a positive slope. So we'll say the water is increasing at a rate of 2/3 degrees C per minute. And we're not done because there's one more part. We covered the increasing rate for that w prime, but we need to now talk about this 12. What does this 12 mean? It means that the water is increasing at a rate of 2/3 degrees Celsius per minute for a specific moment, right? So what is this moment? When t is equal to what? 12 minutes. And that is a complete answer. So you need 3 parts to answer this question. You need to say the increasing. You need to give the units. And then you got to say the time. So those are the parts that you need.